Hello again. So we're going to look at a few more topics here. These are just some random topics, things that I'm not going to devote an individual video to each of these things. But if you did the practice so well, you saw each of these things come up, and I just thought it might be good to show you again how each of these things work. Alright, so this very first problem here, you might already know where this is going. You're asked to solve this particular quadratic equation. Well, remember, the first thing we have to keep in mind when we're solving a quadratic is I have to first get it equal to 0. So my first step in solving this is going to be to add 14, which will give me x squared plus 6x plus 84 is equal to 0. Okay, so now, how would I proceed to solve this? Normally, we like to solve by factoring. Now, you can try and factor this. You can look for factors of 84 that add up to 6. As you might guess, though, the factors of 84, there are none that add up to 6. 84, if you try and break it down, is, among other things, 4 times 21 and 7 times 12. So I'm never going to get really anywhere close to getting a sum of 6. What do I do when I have a quadratic that I need to solve that doesn't factor? Well, what you might recall us doing, and it's on your formula sheet, again, right here is my formula sheet, our famous quadratic formula. All right, so you need to know how to use this, and you need to understand how to substitute in and simplify. So let's take a look at this problem right here. I know that my quadratic formula tells me that the solutions of this equation are x is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Okay, so if I want to figure this out, I need to know what a, b, and c are. Now, this is maybe not the greatest example because here a, b, and c are all positive. And I will tell you that, of course, when you're substituting in here, you need to be extremely careful that you use the correct sign. If they're all positive, that kind of takes that element of difficulty out. A, my leading coefficient is 1. B, the coefficient of x is 6. And C, the constant term is 84. All right, so let's substitute these in and see what comes up. The opposite of b will be negative 6, plus or minus the square root. B squared is 6 squared. I'm going to use parentheses to emphasize that I really do need parentheses when I'm substituting. Minus 4 times a is 1, and c is 84. And I'm going to put all of this over 2 times a, which is 2 times 1. Now I can go ahead and start simplifying this. Now you might recall, you really don't want to rewrite this many, many times. So what instead we're going to do is look at this radical right here. The area underneath, this is called the discriminant. Remember, it tells me the number and type of solutions that this quadratic must have. I'm going to do my work to simplify this off to the side. 6 squared minus 4 times 1 times 84. I can just write that as 4 times 84 because multiplication by 1 won't change my result. 6 squared is 36. 4 times 84 is 336. Again, I'll confirm that that's correct. 4 times 84, 336. All right, so that means that this is negative 300. Now you might recall if the discriminant is negative, this is going to go under a square root, remember. So all of this is under a square root. A negative square root means that I have non-real solutions. I have imaginary or complex solutions. So the square root of negative 300, the first thing I'm going to do is deal with that negative and rewrite this as I times the square root of 300. Well, 300 I know is 3 times 100. And then factor this as you're comfortable. I know a lot of us like to factor by taking out small prime numbers, but that's going to be kind of cumbersome to do here. Instead, what I'm going to do with 100 is take out a 10 and a 10. Okay, so that's actually a perfect square. I could just say at this point that, oh, I have a square, 10 times 10. If you want to break it down more, you're welcome to. This is 2 and 5. This is also 2 and 5. So what I have here is I times the square root of 2 times 2 times 3 times 5 times 5, if I put them in order. Those are squares, so I can take out a 2, I can take out a 5 for those pairs. Outside, I'll have a 2, a 5, and the I that I already took out. So this is 10I square root 3. All right. Now doing that work off to the side is going to make my work much cleaner here, because I'm going to come back up here and say, okay, what I'm looking at is negative 6 plus or minus 10I square root 3 over 2. And now I need to simplify this. Remember how this works in quadratic formula. What I need to look for is a common factor to the denominator, and not just right here or right here, but I need all three of those places to have a common factor. And I'm in luck. I can see right here that all three of them have a common factor of 2. So if I simplify that, I will get negative 3 plus or minus 5I square root 3. So those are the solutions to this original equation I was given. And I say solutions because remember, this does mean two things. Negative 3 plus or minus 5I square root 3 actually means negative 3 plus 5I square root 3, or negative 3 minus 5I square root 3. Hence plus or minus. This represents two solutions. That's just a quick look at how you do a quadratic formula problem. All right. Next up, another topic that appeared on your released SOL, which we haven't talked about recently. Right here, I'm told that g of x is 2x to the fourth minus 5, and h of x is 3x plus 2, and you're asked to find h of g of x and g of h of negative 2. Well, you might recall what I'm doing here is I'm asked to put g of x into h of x. This process is called composition. When I'm asked to find h of g of x, I'm going to take h, which is 3x plus 2, and I'm going to replace this x with g. Here's what it looks like when I'm about to substitute something in. And what am I substituting in? I'm substituting in g. Now g's rule right up here is 2x to the fourth minus 5. Truth be told, if you remember how to do this, this is actually quite an easy problem, because all I need to do here is distribute this 3 and get 6x to the fourth minus 15. I still have this plus 2 down here. And I know then that the composition h of g of x is equal to 6x to the fourth minus 13. Okay? That first part is now done. Second up, g of h of negative 2. This is still composition, but it's in a little bit of a different form. Here, I'm plugging not an x, but I have a number here. So what I want to do here is work from the inside out. I'm going to take negative 2, put that into h. I'll get some numerical value. And I'm going to take that and put it into g. Like I said, I'm going to work from the inside out. So first off, let's figure out what h of negative 2 is. Apologize for the messy work here. H of negative 2 is 3 times negative 2 plus 2, because I can see my rules right there. This is negative 6 plus 2, or negative 4. Okay, so then, what I was asked again for was g of h of negative 2, and what we've just shown is that h of negative 2 is negative 4. So I want to find g of negative 4. Well, g, remember, is 2x to the fourth minus 5. Again, my rule is right up there. I'm not pulling this out of anywhere. It's just write something that it was given to me. Well, if I put in negative 4 here, I have to know what negative 4 to the fourth is. Now, obviously, you can use your calculator. Negative 4 to the fourth will be positive 256. 2 times 256 is 512. If I subtract that by 5, then I will be left with 507. And that's a quick review of how you work with composition. All right. Now I'm going to throw one more topic at you. How important are any of these topics? I can't really say. I can tell you that pretty much guaranteed any and all of them will show up on the SOL. Quadratic formula especially. Composition, again, you should know. It's not ultimately that hard, but it's worth reviewing. Now here's something that we ultimately didn't emphasize probably as much as we should, because these are kind of important in the grand scheme of algebra. But here I'm asked to find the inverse of a function. All right. Now if you don't remember how to do this, the process of finding an inverse means that I switch x and y. When you hear inverse, you better think to yourself, switch x and y, because ultimately that's what you're doing. Now, in this particular problem, I'm shown f of x is equal to the cube root of 3x, or excuse me, the cube root of x minus 11. Well, I need to understand first off that f of x means y. And now what am I going to do? I'm going to switch x and y. So y is the cube root of x minus 11 means that x is the cube root of y minus 11. Well, what do I do here? I need to solve for y. To solve for y means I need to get it out from under this radical. How do I solve? How do I undo a cube root? I undo a cube root by cubing both sides of my equation. So this will leave me with only x cubed. And over here, the whole idea is cubing a cube root leaves me with whatever is in the radicand. Now, how do I solve for y? Of course, I'm going to add 11. And that's y. So this right here will be the rule for my inverse. Now, the other thing about inverses that's worth remembering, worth noting, is there's a special notation. I started with f of x. The inverse of f of x is denoted as f inverse of x with this little negative 1. And that'll be equal to x cubed plus 11. Okay? That's how you find an inverse. Let's take a look at another example. This one's actually going to be a little bit simpler, although the numbers will still be a little bit ugly from one perspective. Here, g of x is equal to negative 3x plus 8. So again, I know that g of x is y. Anytime you see g of x, h of x, f of x, whatever of x, the function's name stands in for y when we're graphing. Alright, so if I switch the x and the y here, what will I get? I will get that x is equal to negative 3y plus 8. And again, I'm going to solve for y. So I will subtract 8, and I will divide by negative 3. Now, I could leave this entire thing over negative 3, but it's probably more likely that you'll see this split up. Rather than being over negative 3, each term will be divided by negative 3, and I will have to simplify this. Well, what am I going to do with x over negative 3 minus 8 over negative 3? Well, x over negative 3 I can write alternatively one way as negative 1/3 x. Negative 8 over negative 3, these two negatives will make this positive, and I will have 8/3. So that's y. Now again, I could have written this a little bit differently. I could have written negative x over 3, very similar to how it was written here, but probably you'll see it written like this, negative 1/3 x plus 8/3. And then again, I've solved for y, so now I will write my final answer using the correct notation. I had g, so I found g inverse is negative 1/3 x plus 8/3. And this is the inverse function. Now, inverses, truthfully, are not ultimately that complicated, at least not for what we're focused on. So you really have to keep in mind that what you are doing is switching x and y. And then if you're doing this algebraically from a rule, you are solving for y to get a new equation rule. Now, there's one other example that we need to be concerned with. Again, this is on the released SOL, the practice SOL that I gave you to work on. What if I give you a function graphically and ask you to find its inverse? Well, again, I just sketched this by hand, so it doesn't look like the prettiest graph in the world. But what does an inverse mean? Inverse means that I will switch x and y. So, okay, I have two options. I could actually use my knowledge of algebra to figure out what type of equation this is, write an equation, go through, do all the algebra, find the equation of its inverse, and then match it up with whatever answer choices I was given. But suppose I don't want to do that because that's going to take forever. Well, look right here. What point is this? One of the points I can see on this graph is 0, 3. Now, if I've drawn this correctly, you can see it also goes through 1, 4, and right here it goes through 2, 7. Now it also looks like it goes up here through 3, 12, but I'm not so concerned about that. Rule of 3 here. If I want to find the inverse, I can generally manipulate it off of 3 points. So these are the points of f of x. When I want to find the inverse, again, inverse means I switch x and y. 0, 3 should become 3, 0. 1, 4 should become 4, 1. And 2, 7 should become 7, 2. So, when I look for something like this, if this is on a multiple choice test, such as the SOL, then what I want to do is look for some function that has these 3 points. I'll sketch it and show you what that should look like. Here's 3, 0, 4, 1, and 7, 2 will be right here. Okay. Now again, I'm switching x and y, which is a transformation where I'm reflecting in the line y equals x. So I want to see a reflection across this line. So it's turned up like this. When I reflect it, I will instead go more like this. And thus I have found the inverse. So that's just a quick look, a live look at how you do that problem, which again, I realize it's on my answer key. But in case you wanted to see it live, that's how you do it. Again, if you're finding an inverse, you need to know that you're switching x and y. Algebraically, we discussed the math behind that. Graphically, take a few points and switch them around. Generally speaking, if it follows 3 points, it has to be your inverse. Again, I hope this has been helpful.